Yo, what's up, everyone? So, we're back with online week 3, and I might not get as far as I want to in trigonometry, but thinking about how to prepare you for next year, what we're going to do this week, I think is really fundamental to the future. We're going to learn some stuff that comes up in math quite a bit, some stuff that you may have seen before, such as the number E, or like the letter E meaning a number, and also like another type of log. So let's kind of just start with something we've seen before. I mean, this exact question we've definitely seen before, but we're going to start with number 2 and talk about how that applies to some of these questions, which you can already see there's going to be a big dilemma. So if we see 2 to the x is equal to 64, what this means is 2 raised to what power gives me 64. And we can just do it in our head. We know that an equivalent statement to that is log base 2 of 64. And in both cases, all it means is this multiplied to itself how many times gives us this number. And something that is important, and even why I keep recycling questions, is that this is really convenient that this number we can multiply to itself continuously and get to this number. Okay? We're really fortunate that this multiplied to itself a certain number of times gives us this number. Right, and we can solve that in our head by just going 2 times 2 times 2, etc. Okay, so when we see this, we know that it's going to come out as a whole number integer as our answer, because this, an actual number of times, gives us this number. Okay, so we're seeing this, but what we're going to try to look at now for number 5 is what happens if the question isn't so convenient. So when we see 7 to the x equals 50, we couldn't just be like 7 times 7 times 7 or 7 times 7 gives us 50, right? It doesn't work out. We know that if we kind of write the factors of 70, I don't even know past like this number, but 50 is kind of in between these two. And if you think about it, let's think if this was the question, the answer would be 2. Whoa. But what I want you to think is that you can actually put a number here that makes this equation work. But that number is not going to be like an integer. It's going to have a decimal. Okay? So if it's going to have a decimal, let's think about what 7 raised to what power would give us 50. If 7 to the second power gives us 49, and 7 to the third power gives us 243, then we know that 7 raised to some power really close to 2, a little higher than 2, is going to make this work. Okay, so hopefully that's kind of making sense to everyone. I think this is really interesting, but just because it doesn't work out perfectly doesn't mean we can't kind of put a decimal here to make this work. So the way that we're going to solve this, and this is kind of how logs become super useful, is we're going to convert this into logarithmic form and see if we can work from there. Okay, and warning, it's going to get a little wonky, but it's going to be really easy. I think this worksheet's going to be really easy. So if this is the question, like if this is our log, we still can't solve this because we know that we do these in our head, and the same dilemma occurs as here. But what we're going to figure out how to do is put this in the graphing calculator. So this is why logs are so important to begin with. Questions like this, without a log, there's no way that you could solve it, even in your head, But here, we're going to figure out there's a method to putting any logarithm in a calculator. When x is isolated, we can just solve this using a calculator. So I don't know if I said this before, but have your iPhone out, because I'm just going to use the iPhone calculator, but then talk about how it works on a technical calculator too, because I know in other classes you got to use like maybe even a graphing calculator. So here's what we're looking at. Log base 7 of 50. How can I put that in the graphing calculator? And if you took out your phone calculator, first, I really hope everyone knows this, but you can get way more functions on this by flipping it. And we're pretty much going to cover like everything. Oh man, that looks really awful. I mean, at least you can see the placement. That's a bummer. Okay. But here's the thing. If we're going to look at this, and this button, you can't see it as well here, but have your phone out. Sorry. Android users. I'm sorry, Gregory. But this says log base 10. And the question is, well, what do we do if we want to put another base here? And we're going to talk about log base 10, but all you have to do, if you want to put this in your graphing calculator, is split this up into 2 logs. So this is a property of logs, and it's really funky, and I'm going to go for the proof tomorrow, which is, you know, pretty complicated. This is one of those things, the math is way easier than the explanation. But another property of logs, like we talked about a few properties before, is that we can turn a base number and a top number log into just 2 logs with no base number. Okay, so tomorrow's lesson is going to cover what does it mean if there's not a base number, but a lot of times when you actually apply these, you're not going to see base numbers, and that's because they're always kind of written out in this longer form. Okay, so again, even though this is kind of funky, we're going to start getting used to not seeing a base number. There's going to be an implied base number, like there's a lot of implied numbers in this class, but this is actually what we're going to input into the calculator. So we're going to do it one at a time, figure out what this is, and then figure out what this is, and just divide. Okay, so someone's trapping outside. Okay, so all we're gonna do is we're gonna press 50, the top number, and then that log button. Okay, so you press the number you want to get the log of first, and then you press log base 10. Okay, so it doesn't work the other way. Like if you just start with log 10, it's going to give you error. But if you want to do any log, you just take that number and get there. So this log base 50 or log 50. So when you see this, you don't even have to say base number. You just can say log 50. Log 50 is equal to 1.69. And then we just do the same thing for the bottom. And you could put it in the calculator, but I'm kind of always cautious. The bottom is going to be 0.845. So we haven't used calculators a lot. We haven't needed to. I kind of like math without calculators more. I think it's more useful, but this is kind of necessary. So again, you have a log, you want to solve it, you split it into 2 logs, and then you input those both in the calculator. And now all you have to do is the top one divided by the bottom one. And I'm just going to use what I'm comfortable with here, and then show you how you could do it in one of these. And the answer is 2. Oh, that's really funny. Okay, I'm going to ground these better and do this again. Because, like, yeah, I'll explain. Okay, so again, so actually now I'm just going to have this be more rounded, because what we saw the first time was it equals 2, and that makes sense because 7 squared is 49, so really close to that. But we'll do this divided by 0.8451, and we'll get 2.01. Okay, and what this means, so this is the answer. And the process, I think, is pretty easy now that we've gotten there. But now that we get this answer, this is actually really cool. Okay, so if you wanted to do an exponent, we're now kind of learning that you can have a decimal exponent. 7 squared would give you 49. But if you raise that to the 2.01, so just a little bit more than 2, that's going to give you 50. And you know, you could round way, way better. This is getting closer, so it's more like 0.02 or 0.008. You know what I'm saying? So that is that, and I think that that's really interesting. So if you raise a number to a decimal exponent, you can get literally any number here. It doesn't have to be one of the root numbers. Okay? So hopefully you guys think that that's really cool. We're going to do number 7 now. And with number 7, we're just going to be technical. And I kind of like to always end with a question that's going to make the whole thing seem a lot easier. And for this, we already have this log. And what we can't do is just 20 raised to what power gives us 4. And first, this base number is smaller. But we know that's okay, because if we raise it to a fraction or decimal exponent, the number gets smaller. So this is going to be fine and solved the same way, but couldn't be solved in our head, because 20 squared gives us 400. All we're going to do is rewrite it as 2 logs. And I think I glossed over this, but the top number goes up here on the top, and the base number goes down here. So when you're looking at this, I think that that's kind of easy. The top number stays on the top, the bottom number stays on the bottom. And then all you're going to do is put them in the calculator. So I'm using my graphing calculator for this one, and a lot of times I was actually kind of interested that the iPhone said log base 10, because that's tomorrow's lesson, but usually it just says log. So we'll do log 4 and log 20. And the way I'm just going to do this is now that I can do it for that number. Clearly I'm not that good at the calculator. Log 4 divided by log 20. Okay. So the top here, log 4, is 0.602. The bottom is 1.301. And that's enough rounding. That's really fine. This is kind of a good time to practice some decimal stuff, because most of the stuff we've done this year hasn't been decimal at all. But definitely won't be the case moving forward. But this is going to end up being 0.462. So that's the whole process, and I think that's pretty easy. And then you can always check your work by taking this number, raising it to this power, and seeing if you get that. So you could do 20 raised to the 0.462, and that's like 3.99, so basically 4. And like on the graph, let me show you on the iPhone. We could do this one, y root x, and all that's saying is no, x raised to the y, and all that means is put a number in, raising it to the 4th power. No. Put a number in, you press that. We're trying to check our work, so we're raising it to the 0.462, and it's 3 point. Okay, I got to do it again. And like the way you could check it on the graph calculator is you use x raised to the y, and you put the first number in, so 20 raised to the 0.462 to check our work here, and it gives us 3.99. Okay, so that's the lesson, and I think that these practice problems are going to be really easy. They're either going to be like this, turn it into a log, or already a log. And we're going to expand this week. It's a lot of interesting but pretty easy stuff. So good work today. Hoping to get the next worksheet soon. Proud of you as always. Woo, 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 woo.